Hi, welcome to Bloom. Today's lesson is an extension of the previous lesson in Chapter 3 Data Representation of GCE A-Level syllabus. In the last video, we learned about character encoding methods, especially focusing on ASCII and Unicode. In this part, we will be discussing more about Unicode character set and encoding mechanisms in detail. This is the basic multilingual plane I mentioned previously. Here each box represents 256 code points or characters. In UTF-16 encoding, code points are denoted by 2 bytes. So if we convert this binary 2-byte value, we can write it in using 4 hexadecimal values. So in UTF-16, the English characters are represented within the first 127 code points. For example, capital A is denoted by decimal 65, so it falls within this range. So here we can see Latin script is marked in black color, so it's correct. Then you will be thinking how the characters of other languages are represented, how they are distributed in this basic multilingual plane. For example, if you take Sinhala, which I mentioned previously, it is a South and Central Asian scripting language. It should be marked with green color. The code point range for Sinhala characters is from 0D80 to 0DFF. So here we can see 0D range is marked in green color, so it's correct. Then we have a huge set that is dedicated for CJK characters. It is dedicated for Chinese ideograms. Since Mandarin or simplified Chinese, it's not a character-based language but an ideogram-based language. It needs a lot of code points to input the words of that language. In the current version of Unicode, almost 90,000 ideograms are represented. Then we have some other parts which is called dedicated for private use and some part for UTF-16 surrogates. We will talk about character surrogating in future videos. Here we will see what's the difference between UTF-8 and UTF-16 and also UTF-32. So let's take the character capital A. In standard ASCII representation, it is represented using decimal number 65. So when we encode it in UTF-8, it can be represented using 1 byte. 65. This is 65. Decimal number 65. In UTF-16, we use 2 bytes. So it's represented in this manner. Then in UTF-32, we represent a character using 4 bytes, and so here we can see the binary value 65 and the rest of are filled with zeros. Now let's see how other characters in another language is represented. This is a Japanese character. It's a CJK character. So in UTF-8, it is represented using 3 bytes. Normally in UTF-8 we use 1 byte, but we sometimes use 2 bytes to represent characters in languages such as Arabic, Hebrew and other European script. Then the BMP, Basic Multilingual plane for UTF is 3 bytes. So here we can see this character is represented using 3 bytes. In UTF-16, the normal BMP is 2 bytes, and there are instances where all 4 bytes are used, which is equivalent to the Unicode character set. So let's say we are using only English characters in some work. So most of the time what we need is standard ASCII encoding. So going with UTF-8 is better as it only consumes 1 byte. If we use UTF-16, it always consumes 2 bytes. So since these are zeros, it is a unnecessary memory usage. It doubles the memory usage. So if we are only working with English characters, it is better to use UTF-8. But let's say if you are working with non-Latin characters, we can see that in UTF-8, 3 bytes are consumed, whereas in UTF-16 it consumes only 2 bytes. So if you are working with non-European languages, the most best memory usage is in UTF-16. If we use UTF-8, it always takes 1 extra byte of memory. When we are discussing BMP, we came across surrogate characters. So what are those characters? These characters have some special values and do not have a valid representation in Unicode. Therefore, Unicode has introduced a special method to allocate a code point for surrogate characters, and they are made up of 2 Unicode characters in 2 specific ranges. The first range starts from DA and the second range starts with DC. If one of the pairs is missing, then not in the order, then it is an invalid character. So let's see an example of surrogate pair. Here we have this pair 1 and this pair 1, 2 code points. This is the high surrogate. From the first 6 characters you can see it belongs to D8 range, and the low surrogate, which is followed by high surrogate. The first 6 characters shows that it belongs to DC range. Then the remaining 10 characters here and the 10 characters here, altogether 20 characters, will represent a special character. So this is all about surrogate. So this is an example of a surrogate pair. Thank you for watching our video. Stay subscribed to watch more lessons.